Our previous video showed you how to visualize your data using histograms, and we're now going to show a way to, rather than look at the distribution of your data, but rather to plot the relationship between two variables, and we're going to do this using scatterplots. So first we're going to focus on some of the theory behind what a scatterplot is, and then we're going to give you a practical demonstration of how you can use Excel and pivot tables in order to graph your data and create your own scatterplots to start investigating the relationship between variables that you're working with. So we've already looked at summary statistics to summarize our data with a couple of key numbers. We've also looked at plotting our graphs as a histogram in order to show the distribution of our data. What we can use scatterplots for is to show the relationship between two variables. Maybe we want to look at, instead of just the overall distribution of math and EFL marks for learners, maybe we want to see for specific learners, do learners who do well in maths also do well in EFL? How closely are those marks correlated or related? And for that, something like a scatterplot is very useful. So if we wanted to show the maths versus the English First Additional Language marks, we can plot it like this. So here we have maths on the x-axis and English First Additional Language on the y-axis. And if we had a learner which had a mark of 47 for maths and 53 for English, we can plot that learner as a dot on our graph. So we connect those two marks, and where they connect, we put the dot representing a learner. And we can then do this for all of our learners in order to see the relationship between these two variables. Something to note here as well is that the dot doesn't necessarily have to represent a learner. It could also represent something like a school. So this example over here is from work that RESEP has done in the past, where we were looking at how learners, or this was at school level, so each dot in this graph represents a school, and we were looking the average maths mark of matric learners in term 2, how did that compare to the average math mark of the same learners on the end of year examination? What you can see over here is that, first of all, if you look at a red line, which is the line showing equality, so a term 2 maths mark of 20 would correspond then to a final NSC maths mark of 20 for the school. Most of the dots lie to the left or above that red line that's shown in the graph. What this tells us is that for most schools, their average NSC maths mark was higher than their average term 2 maths mark. So a school which had 20 in term 2 for the matriculants, they got usually a higher mark than 20, so maybe like 30 or 40 on the matric exams, which is unsurprising for most of you working with matrics, in that often the marks do improve from term 2 to term 4 because you're repeating the same material over and over again to prepare for the matric exams. You can also get information about outliers or schools which are very different from the rest of them. So here's a school which you would have expected them to get a much lower mark, but they were very high. You can see they're far away from the other dots. And then you can also see that there does seem to be some relationship. It's not like these dots are just scattered all over the place. There is a bit of a line there clumped together. So this also then shows us an advantage of a scatterplot. It shows us that there is some relationship between these marks. So what I've written here is that schools' average term 2 marks and their NSC marks, they do seem to be related in some way. And there was a way that we can actually measure this relation rather than just like eyeballing it and say it kind of looks like there is a pattern there. We have something called a correlation coefficient, which is a value. I won't give you a formula. Computers are quite good at calculating it, but the interpretation is what we'll focus on in this video. So the correlation coefficient demonstrates, or it's a measure of how closely the two variables that you're looking at are related. And I will also just mention here, it's important to remember that just because two things are correlated, it doesn't mean that there's a causal link, so that one causes the other to happen. It just means that they are related. Maybe you can predict. So if you know one mark and things are very well correlated, you can then predict the other mark with quite high accuracy. Our correlation coefficient is a value which ranges between -1 and 1. And there's a variety of ways to interpret it. So if there's a value of 0, what that tells us is that there's no linear correlation, or there's no relation between the two variables. If it's +1 or -1, so those two extreme values, that means that there's perfect correlation. So if you know one variable's value, you're 100% certain of what the other variable will be. So if one goes up by 1, the other one goes up by 1 as well. Or if one goes up by 3, the other one always goes up by 1. That would also be a perfect correlation. You always know that that's going to happen. This is, of course, very rare because usually we can't predict things equally. But maybe, let's say, a textbook has the same price all the time. You know, for every 200 Rand you spend, you're going to get 1 textbook. That would always be correlated. For every extra 200 Rand you spend, you would get an additional 1 textbook. If the value is negative, so between 0 and -1, what that means is that if there's an inverse relationship, when one goes up, the other one goes down, or vice versa. An example of this in education is usually when learner absenteeism goes up, we would expect that achievement would go down. So those things might be related, but they move in opposite directions. If we tie this back to scatterplots, intuitively, to try and see visually if things are correlated or not, you can ask yourself 2 questions. So the first one is, how well can you draw a straight line through the data that fits the dots that you're seeing? And then the second question, to see the strength of the relationship, is how close to this line do the observations fall? So over here in this graph, let's say we could draw a straight line through all of the dots, and all of the dots lay on the line, and it's a downward sloping curve, or a downward sloping line. That would then align with the correlation coefficient, which is often represented with an R, of -1. So perfectly inversely correlated. If the line that you drew was upward sloping, so like this one over here, and all of the dots lay on the line, that would then be +1. So perfectly correlated, but in an upward sloping manner. And it doesn't matter the gradient of the line, so how steep it is. It just matters, can you put them on the line? These 2 graphs over here are examples where you can draw a line through the data, but they don't all fit very closely. So you can see in this graph, it's a downward sloping line, so it's negative, because they do generally seem to move downwards together. And they are quite close to the line, but they're not perfectly on the line, so -0.6. Whereas in this graph, if you were to draw a line through it, it does seem like there's maybe an upward slope, so it's positive, but the dots are all much further away from the line. So you can see that the value of this is smaller than when they were more strongly correlated, the 0.3 compared to the 0.6. And the sign just indicates, is it upward or downward, the relationship. One thing to note, though, is that if the line that you draw through the data is perfectly horizontal or perfectly vertical, then there's still 0 correlation. So like these 2 graphs shown over here, even if the dots lie on the line. And that's because, remember I said that correlation will allow you to predict. Over here, if you know that, well, the y value will always be this, but you can't predict what the x is going to be because the x could be anywhere on the line because it's perfectly straight. And the same as if we had a vertical line.
So I'm going to use the same data that we used for the histogram and for the summary statistics to draw a scatter plot. And I want to compare 2 scatter plots. The one is the relationship between the grade 9 maths and English first additional language, and then also a scatter plot for maths grade 9 and the natural sciences also grade 9. And I'm going to do that for a specific school. I'm all going to do that all on one page. So start with a pivot table again, Control A, insert, and OK. So I'm going to look at the performance of learners. And this time around, I want to use the subject as columns and the mark as the values. Make sure that the mark is a sum. I want to filter this, use this column filter and use it for English first additional language or grade 9. And then also maths, grade 9. So those are the 2 subjects, and I'm going to draw a scatter plot on that. So this is the first pivot table I want to use, is English first additional language and maths grade 9. I'm going to draw a scatter plot on that. Let me first filter this also by school. And there's a reason why we want to filter it by school, because these subjects within this data set is not standardized tests. So the standard between schools might differ. So that's why we use a specific school when we compare these subjects. So I want to look at the EMIS number of a specific school, and the EMIS number we want to use is the one that is 1002 003 06. That's the school I want to filter it for. So now I want to copy the same pivot table and paste it right there. But this time around, I want to filter this for Maths grade 9 and Natural Sciences grade 9. So those are the two pivot tables. Now I want to draw two scatter plots below each other so that Rebecca can compare the English first additional language and Maths versus the Maths and Natural Sciences. And I also put in a correlation for each one of those scatter plots. And to do that, you need to be outside the pivot table. So I'm first going to have a scatter plot for this pivot table on the left, which is English first additional language and Maths grade 9. You need to be outside the pivot table and then go to Insert, and then you get this cluster of different graphs, and this is the one for a scatter plot. So I simply click on that and I select the first one. Then I get this blank graph with nothing in it. Now I'm going to build the scatter plot, and to do that I need to select the graph, right click, and then use the Select Data option. And then with this dialog box, I can now build my scatter plot. So I simply go to Add, and my X values, I'm going to use my English first additional language first in this school. And then again, I don't want to include the total. I simply go and select that. So that's my X values. And I go back to this dialog box here and then click on the arrow. Now I want to populate my Y values. And click on Y, and in this case the Y in this scatter plot would be my Maths grade 9. Go to the end of the data and select my Maths as the Y values, and then go back to my dialog box here and say OK and OK again. And now you can see this scatter plot, this is my English first additional language or versus Math. And this is for grade 9. So this is my first scatter plot. What I want to do also with this scatter plot here is I want to add that trend line which Rebecca showed in her theory part. So to do that, you can click any dot, right click, and then there's an option that says Add Trend Line. And now you can see I've added a trend line, but I want to make this a little bit more visible. So I click on the trend line and then use my paint bucket here. So I'm going to change that to red and then change the width to 3 so that it's clear to see. So that's the trend line for English versus Math. So that's important that we also have titles for each of these axes, the one for the x-axis and the one for the y-axis. And to do that, again, I click on the graph and then the plus button here on the right, I click on that. And then I want to add the axis titles. And I just simply click on that. Now you can see this is for the X. In this case, the x-axis was English first additional language. And the Y in this case here was for Maths grade 9. So then you know for interpretation that's very important that you can distinguish between these two. So this was the scatter plot for English and Maths grade 9. Now I'm going to draw the same scatter plot just below this for Maths and Natural Sciences. Again, you need to be outside the pivot table. Go to Insert. Select the scatter plot and the first one, and again you get a blank one. Now I'm going to build this scatter plot using exactly the same steps. Right click, select data, add, and then the X values. In this case, Maths would be my X value, so I select all and go back and then select my Y values. Then that Science is my Y values, go down and one up. Go back and say OK and OK. You can see now I have my scatter plot. This one to make sure that my chart title, in this case, this was Maths versus Natural Sciences. And again, I want to make sure that I have the axis titles. Again, I just click on plus, put in the titles, and here, in this case, the X title was Maths this time, and the Y was natural sciences. The last thing that I want to do is to add a trend line. Again, I simply add a trend line, and then again I want to change the color to red, and then change the width to make it 3. The last thing I want to do on this page is I want to work out the correlation for English versus maths, and then in this case for maths versus natural sciences. And to do that, the command for the correlation is simply equal sign and COR. And in Excel, the command is just correl, CORREL. And then I hit the tab key. And now I'm first going to do the correlation for English versus maths. So again, I go to my pivot table, shift control arrow down, and I don't include the totals. And then the important is once you have the X values, you need to separate that with a comma. That's important. In some instances, your computer is set that the separator could be a semicolon. In my case, it's a comma. So I put in a comma. So that would be my X values. And then my Y values, I go back to maths in this case. Shift control arrow down, and I don't include the total. And then simply hit enter. And you can see in my case, it is 0.57. That's the correlation for the relationship between English, first additional, and maths. We do the same correlation for maths versus natural sciences, and then compare the two. Again, and this time around, I use the pivot table on the right. And here my maths is my X values. Then I separate it with a comma. And then natural sciences as my Y values, and hit enter. And now I have everything that I need to compare. And you can see in this case, you want to get rid of my decimals. In this case, it's 0.67. And so Rebecca will explain all of this to you.
Okay, so interpreting these graphs, what I'll do is I'll just zoom out so we can see both of them at the same time. And I'll make this one a little bit smaller. So in our pivot tables, each row, remember, represented a student. So this was a student who got 33% for maths and 41% for natural sciences. So they would be somewhere 33 and 43. They'd be one of these dots over there. So we've plotted all of that. So we can compare now that we plotted the dots for all of the learners. We can see what sort of relationship exists between the variables and how does it differ by subject. If we look at the EFL versus the maths, you can see that there is some sort of correlation. They're not completely randomly scattered all over the graph. But there is also a fair amount of scattering. So if you look at maths versus natural sciences compared to the EFL versus maths, there does seem to be a bit of a stronger relationship between the natural sciences and the maths compared to the EFL and the maths. And that is reflected in our correlation coefficients. So the 0.67 is greater than the 0.57. There is a higher relationship or a higher correlation between grade 9 learners in this school, between their maths and their natural science marks compared to their maths and their EFL marks. And just to note, it doesn't make a difference whether you have maths on this axis or natural sciences on that axis. It will change the shape of a graph a little bit, but it won't actually change your correlation coefficient at all because it's just transposing the graph. Where this is potentially relevant is maybe you're interested to see in the FET phase which subject marks might affect another subject marks. So we would presume maths and physical science, for example, are quite highly correlated. And if you're doing poorly in maths, you're probably going to be doing poorly in physical science as well. So that's a hypothesis we might have, but then you can use scatterplots and pivot charts to actually check this. Or maybe you want to compare term versus term performance. So how does a learner's term 2 achievement affect their term 4 achievement? And then you can design interventions or identify schools and learners where there might be a problem. Because if you then know the term 2 mark and it is closely correlated to the term 4 mark, or you can predict the term 4 mark, then you have enough time to intervene. In today's session, all of the examples that we looked at, it has been fairly simple, so just limited to a single school or to grade 9 is the grade we've mostly focused on in 1 or 2 subjects, but this is incredibly flexible. So you can use pivot tables, and there are a number of more advanced methods or different ways to do this, but hopefully this will give you a template for how you can start to use your own data to visualize your data with histograms and with scatterplots, and to summarize the data with your descriptive statistics.